Let us do another numerical which is based on photoelectric effect. The numerical is when EM radiation of a wavelength 300 nanometer falls on the surface of a metal, electrons are emitted out with kinetic energy of 1.7 into 10 to the power 5 joules per mole. Find the work function of the metal and maximum wavelength to cause photo emission. So this is what is the data which is given to us, and the incidental radiation is having a wavelength of 300 nanometer. Now we know the formula that on whenever any metal is incidented with a radiation, electrons are knocked out. Formula is the kinetic energy is always equal to h nu minus h nu naught. This is the energy of the radiation used, and this is what is your work function. Now, once we know these formula, we know the kinetic energy of the electron, which is this one, is already given, and this is how much? 1.7 into 10 to the power 7. We have to find out the work function, and the radiation emitted out is incidented is having a wavelength of 300 nanometer. So using this formula, first what we will do is, we know the wavelength of radiation incidented is 300 nanometers. So the energy associated with this will be hc over lambda. It will be 6.6 into 10 to the power minus 34, 3 into 10 to the power 8 upon 300 into 10 to the power minus 9. So this comes out to be, this will be your 6.6 into 10 to the power minus 34, 3 into 10 to the power 8, 3 into 10 to the power minus 7. This 3 gets cancelled, minus 7, and this will make it 10 to the power 15. So this comes out to be 6.6 into 10 to the power minus, if you subtract this, this will become 19. So the energy associated with this one is this much joules. So this is the energy for your energy of the radiation. Now we are given kinetic energy of electron knocked out, which is 1.7 into 10 to the power 5 joules per mole. So for 1 mole of electrons is this much, and we know that this is this kinetic energy with which the electrons are knocked out. Now this energy, which is the energy of the incident radiation, is this much. So we can find out the work function, which is the difference of the two. But the problem is this, that what we have to do is, we have to convert this energy, which is actually for 1 photon, or which is one for the 1 electron, into moles. This can be converted into moles by multiplying it by the Avogadro number. So the energy of radiation incidented per mole is 6.6 into 10 to the power minus 19 into 6.02 to 10 to the power 23. So this comes out to be 10 to the power 4, 6.6 into 6. So this is 39.6 into 10 to the power 4, or it is approximately 3.96 into 10 to the power 5. So this much is joules per mole. So now we know the energy of the incidented radiation per mole is in 3.96 into 10 to the power 5 joules per mole, and the kinetic energy of the electron which are knocked out is 1.7 into 10 to the power 5 joules per mole. It means what? We need to understand this. These are the two values we have. This is your this value, this is the kinetic energy is your this value. So the difference is, let us do this. So therefore, work function which is your h nu naught is also represented as omega is your h nu minus kinetic energy of the radiation. This is the energy of the incidented radiation which was coming out to be 3.96 into 10 to the power 5, and the kinetic energy of the electron was 1.7 into 10 to the power 5. So this is 3.96 minus 1.7 into 10 to the power 5. So this comes out to be how much? This will be your 6, 2, this is 2.26 into 10 to the power 5 joules per mole. So this is the work function. This much of energy is the minimum energy which is required to knock out an electron from this metal surface. Now, we were asked also to find out the wavelength associated with this, which is also called threshold frequency or threshold wavelength. We are not supposed to find out the frequency, we are supposed to find out the wavelength. Now, after finding out the energy associated with the minimum energy required to knock out the electron, which is also called the work function, let us find out the wavelength associated with it. But first we have to change this energy which is in terms of moles into the electron energy for the one electron. So this can be done by dividing this figure by Avogadro number 6.022 10 to the power 23. So this comes out to be 3.76 into 10 to the power minus 19. So this is the value which comes out to be usually, if you 23 will make it minus 23 will make it 18, and 3.76 is the one value. Now once we know this value, this is in terms of the joules, let us find out the wavelength associated with it. The wavelength is equal to hc over lambda. So your lambda will be equal to hc over E, which is your E is your energy, which is this one. Let us put the values now here. Your h is 6.626 into 10 to the power minus 34. Speed of light is 3 into 10 to the power 8, and this is your 3.76 into 10 to the power minus 19 joules. So this is in joule second, this is in meters per second, this is your in joules. So everything gets cancelled. So what we can get is we can get the wavelength out of it. This will make it minus 19 will make it this much plus 27 will make it 10 to the power minus 7, and this can be worked out as 5.26. So this is 5.26 into 10 to the power minus 17 meters. So this is the wavelength which is actually is the one which is the minimum one which is required to knock out an electron. So with the help of these type of this formula, we can find out not only the wavelength associated with the knocking out of an electron, we can also find out the work function and the minimum energy or minimum energy required to knock out an electron, or we can also find out the kinetic energy of the electron associated with this photoelectric effect.